Welcome back.
Hi everybody, welcome back.
We're ready to do 5.3.
We got some more identities for you today. So.
More. We've had 3 classes without new identities.
Oh goodness, well we need some more identities.
Yeah, I'm kind of getting bored of the old ones.
Okay, we're going to do some fun ones today.
All right, here we go. We got sum and difference. Guess what that means?
Add and subtract.
Weird. Okay, so here we go. These are all the new identities. Well, actually half of them. We're going to fill up the other half. Okay? Now these are pretty simple to remember, and Mrs. Cofield's got some weird little ditties to do, and she's going to dance for you. And
I'm not dancing.
Okay, well, she doesn't think she's going to dance, but we have sine of a plus b. Now here's what you got to understand. These are functions. They have to follow certain rules. Logarithms. When we had a logarithm of x times y, we could not just distribute a logarithm. It was a function of some of the stuff that's inside that function. It had specific rules for logarithms. Sine, cosine, and tangent have specific rules you have to use. And there they are. If you are adding 2 angles, A and B are going to be angles, we are going to follow this rule, and you are going to memorize them. All right. Can you hear them groaning?
It's okay because they haven't heard my song yet.
All right. Sine of A plus B is sine of A, cosine of B, plus cosine of A, sine of B.
So A is just kind of like the first angle?
A is the first angle, and it stays at the first spot each time.
Okay.
And we just take the sine of A and the cosine of the other one,
okay,
and then we switch them.
Okay.
All right? So if we follow that same pattern, sine of A minus B is going to end up being, we're going to take the sine of the first one and the cosine of the second one, and then we're going to switch. We're going to take the cosine of the first one and the sine of the second one. But if the sine here was plus, the sine here was plus, so guess what the sign in the middle is?
A minus?
A minus.
Okay.
And so we're going to get this idea that when we use the sign of A plus B or A minus B, the SIGN sign
is the same.
Is the same.
Sine, sine, same.
Sine, sine, same.
Got it.
Got it. All right. Cosine.
Cosine.
Cosine of A plus B. We take the cosine of both and the sine of both, and we subtract if we are adding the 2 angles together.
Does cosine have to go first?
Cosine has to come first because
okay,
subtraction has to be done in a specific order.
Okay.
Okay, so we have cosine A, cosine B, and then minus sine of A, sine of B. So what do you think cosine of A minus B is going to equal?
So how about cosine of the first one A?
Cosine of A.
And cosine of the second one B?
Cosine of B, so cosine of both.
Okay.
And then we're going to take
sine of A.
Sine of A.
And sine of B.
And sine of B.
Okay.
But instead of a minus sign, guess what we're going to have in the middle?
A plus sign?
A plus sign.
So they just switch.
They switch.
So cosine sign is opposite?
Opposite.
Okay.
So the sine sign stays the same, and the cosine sign is the opposite.
Okay, I have to interrupt now.
Okay.
Because before you go any further, we got to memorize these, okay?
This will be more fun, I promise.
I have to give credit to Mrs. Wilson because she taught me this. And we tried to get her to come video with you, but she has to teach a class or something, whatever. Okay, so here's the rule, all right? So it's got this little ditty thing. Okay, maybe a little dancing. So the sine of A plus B, here's how you remember it. It goes sine, cosine, cosine, sine. Right? And then we go over to cosine and you go cosine, cosine, sine, sine. Get it? Okay, let's try it again. So the sine, always start with the sine. Sine, cosine, cosine, sine. And then it goes cosine, cosine, sine, sine. Got it? Mr. Like he almost does it.
Almost.
Almost. So
I will.
If he can almost do it, you can totally do it. Okay, so come do tangent, and then I'll show him a cool one for that.
Yeah, she got another one for that one, too.
Sine, cosine,
okay,
cosine,
they really
sine.
do help.
Cosine, cosine, sine, sine.
Really strange, what are they called? The sayings that we have for the other Pythagorean ones?
Mnemonics and stuff, yeah.
Yeah, the weirder they are, the less you'll be able to forget them. I don't care how many years of therapy you have.
Did you just call me weird?
We're just going to move on now.
Okay, next.
Tangent of A plus B. Wow, that's fun.
Ew.
Okay, by the way, we're going to prove some of these in class and see how where they come from and not just throw them out there for no apparent reason. But
okay,
we'll wait till the worksheet's in class. For now, we just want to throw them out there and start using them. Tangent of A plus B is tangent of A plus tangent of B. So we take the tangent of both and add them together.
And again, first thing, second thing, right?
First thing, second thing.
Okay.
First angle, second angle.
Okay.
And then on the bottom of this fraction, we have 1 minus tangent of A times tangent of B. And of course, we have a weird looking ditty, or sounding ditty, for that one as well. But pattern recognition, if this was a plus, and this turned out to be plus, and that turned out to be minus, how do you suppose we're going to do tangent of A minus B?
Okay, so it would be tangent of A.
Tangent of the first one.
And then the sign was the same on top, so minus.
Minus tangent of B.
Okay. And then on the bottom we would have, is the 1 always there?
The 1 is always going to be there.
Okay, so 1 plus.
Plus.
And then tangent of A, tangent of B, and they're being multiplied.
Tangent of A times tangent of B. Now, the way we remember this too is that the tangent is going to have the same sign on the top.
Okay.
And the board's a little off. Let's move that up here. Same sign on the top and the opposite sign on the bottom. That little blank is more of a fraction bar. How's that?
Okay.
And that's easy to remember if you remember that tangent was sine over cosine.
Oh, right. And sine was the same.
And sine was the same, and cosine was opposite, so it's the same on the top and opposite on the bottom, and it kind of fits.
Cool.
Probably because that's how it gets proved. All right?
Cool.
However, what you've all been waiting for
is me to tell you how to do it. Okay, but it all has to go together. Okay? So sine and cosine have this little kind of feel, right? But tangents got a little different feel. So it goes like this. It goes tan plus tan over 1 minus tan. You got to get your boom in there. Okay? So let's do the whole thing. You got to do them all together. So it goes sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Tan plus tan over 1 minus tan. I think that's syncopation if you ask the music people who really know.
What the heck? Watch your language.
I think it's called syncopation. Somebody find out for me and let me know, okay? So anyway, how the heck are we going to use these crazy things? All right, I'm done being crazy. Not really.
No, I don't
Your
think
turn.
you can't take crazy out. Okay.
It won't go away.
All right, so we are going back to our idea of proving identities. Now keep in mind, all the identities we learned the last 3 days are still up for grabs and usable.
Okay.
The new ones we're going to use here, okay? But we have to prove this. So cosine of pi plus theta we want to show equals negative cosine of theta. So we're going to start with the left side.
Okay.
With the left side.
You can just put LS for
I
this.
left side, LS. Okay, here we go.
Okay.
Now, we have a cosine of a pi plus theta. That is a sum of two different angles.
Cosine, cosine, sine, sine.
So we have cosine, cosine, sine, sine. I just don't have any rhythm. It's just not rhythm. Okay? Okay, so we have cosine, cosine, sine, sine. That's
Yes,
basically what we've got.
Yes, we do.
And we need to do this in the same order. So it's cosine of pi times cosine of theta times sine of pi times sine of theta.
And cosine sine was opposite, so it's a minus in the
So
middle.
instead of a plus, we have a minus.
Cool.
We have now used our sum and difference formula.
Cosine, cosine, sine, sine.
Now we just have to actually simplify it. What is the cosine of pi? Well, a long time ago, a couple weeks ago, we figured out cosine of pi. Pi was over here. Cosine was the x value. Yes?
-1.
-1 times the cosine of theta, which we don't know how to simplify.
That's cosine theta.
Minus sine of pi, and
0.
sine was the y value, so it's 0 times sine of theta. And 0 times sine of theta is 0.
Fine.
So that is gone, and we have negative cosine of theta, which is what I wanted originally.
Yay!
Okay, let's try the second one.
Hey, Mr. Lecky, isn't that the co-function?
It is a co-function identity. We never really proved it.
Oh, we didn't? Okay.
We just kind of showed how it worked, actually.
Let's prove it.
Let's prove it using the sum and difference formulas, okay? Which means, by the way, if you forgot some of the co-function ones, but you get this one down, you got a few less to remember. How's that? Okay? So sine of pi over 2 minus theta is a difference of two angles, but it's the sine of the difference of two angles. So what's the ditty?
The ditty is sine, cosine, cosine, sine.
All right, so we have left side here. We're going to go sine of pi over 2 minus theta. It's going to be sine, cosine, cosine, sine.
Very good.
All right.
There's hope for you yet.
I don't know. I think I gave up. All right. So that's pi over 2, then theta, then pi over 2, and theta.
And again, the angles always stay in the same order.
Same order. Don't switch them around.
Okay.
What does the sine do when we're doing the sine of two angles
The
subtracted?
sine, sine, same.
Sine, sine, same, so that's a minus. Okay. Now we just have to simplify.
Okay, pi over 2.
Pi over 2 was straight up.
Yep.
That point was 0, 1. So what's the sine of pi over 2?
1.
It's 1 times cosine of theta minus cosine of pi over 2.
0.
0 times sine of theta. And that's gone.
Because that's 0 times 8.
And we get cosine of theta,
Which is what we wanted.
which is what we wanted. And we're
Yay, us.
happy.
We're smart.
Smiles everywhere. All right.
My turn?
Your turn.
Okay, so not only can we use the sum and differences identities, if you will, to expand things and then simplify from there, but we can also go in the reverse order. So if you notice on these ones, we're going to write the expression as the sine, cosine, or tangent of a single angle. So in other words, we need to kind of squish them back together. Okay? So, and it will evaluate if that's possible. So when we look at letter A, we see
Sine, cosine, cosine, sine.
Is that sine or cosine?
It's sine.
It is sine. It is the sine of two angles. We know the two angles are 95 and 55. We just have to figure out what we are doing with our 95 and our 55. Well, the sine was?
Same.
So in other words, we are
Plus.
adding. And 95 and 55 is?
150.
Okie doke. So we need the sine of 150.
We could do that.
We could do that because we all got really good grades on that test. At least my kids.
I did.
You did? You got a good grade?
I got them all right.
150 is going to be over here in the second quadrant. The reference angle is 30 degrees. You can either use your triangle or use your table. But the answer would be?
1/2.
1/2. Is it positive or negative?
It is positive because of the S quadrant that we are in.
Yep. Remember, all students take classes or whatever other things you say that you're not supposed to. All right, we're
Next.
done. That whole big mess equals 1/2. Letter B. We've got the cosine of pi over 4, the cosine of pi over 3, and then we've got sine. So we've
That's
got
cosine, sine.
So is that sine or cosine?
That would be cosine.
That would be cosine. Again, we're doing either a sum or a difference with two angles. The two angles are pi over 4
And pi over 3.
and pi over 3. And are we adding or subtracting?
We're doing the opposite of whatever it is you're doing in this problem. So we're adding.
We're adding.
Your head was in the way.
Sorry. My head was not in the way. It casts a shadow on the board. Here, use your paper. All right, so what are we going to do with pi over 4 and pi over 3?
Add them together.
We need to add them together. We need a common denominator.
That would be 12.
That would be a 12.
And 3 pi plus 4 pi would give me 7
So we're
pi.
going to times this one by a 3. I'm just going to squish it in there. Times that one by a 4.
I love fractions.
Okay.
7 pi.
3 pi, 4 pi makes 7 pi
I'm hungry.
over 12. Can we do anything with 7 pi over 12?
Nope. 'Cause
Why
it's,
not?
It's not pi over 6, pi over 2, pi over 3, pi
Right.
over 4.
It's not one of our special triangles, okay? So we can't do anything with that one.
So we're
We can
done.
Stop right there.
Yahoo.
How do I make it? So now we have tan plus tan over 1 minus tan. So that's obviously
A tangent,
A
function
tangent.
of two angles,
And the
either
two
added or
angles-
subtracted. How do we tell which one we're going to do?
well, the two angles are what, first of all?
20 and 34.
20 degrees and 34 degrees.
And we
Okay.
started talking funny for some reason.
All right, so we're going to, tangent sine on top was the
Same.
same. So we're going to be adding our 20 and our 34, which is,
54?
so we have the tangent of 54. Again, is that going to create a reference angle that's one of our special triangles?
Nope.
So we are done. Finito. Stop there.
I don't know what language that was,
That's
but
it.
okay.
Okay,
All
what
right.
else can we do?
Now we can go the other
We
way.
can go the other way. So we can squish them out. We can stretch them out. Your turn.
And now we can use these identities to create ways to find the sine, the cosine, and tangent of a few other angles that aren't actually part of our unit circle. But the key is to use unit circle angles.
Okay, so we know 30, we know 45, and we know 60.
30, 45, 60. In fact, I'm just going to go over here and put them here. 30, 45, 60, and we're going to go sine, cosine, tangent from our chart before.
Okay.
You don't have to use the chart, but that was 1, 2, 3, 3, 2, 1. Just as a refresher, take the square root of all of them, divide them by 2. La da 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 da.
Then divide
Tangent was sine
1
over
over 3,
cosine,
1
1
over
over
3.
square root of 3.
1
1.
and square root of 3 over 1.
Square root of 3. Okay. So we're going to try to use 30, 45, and 60. We could go so far as going 90, then 120, then 150, then 180.
So any multiple of
135.
those three.
Yeah, we can keep going around the unit
Okay.
circle, but use the points that give us the crazy triangles of 30, 45, and 60.
Okay.
All right, so the sine of 15. Well, why don't we figure out a way to use one of those three numbers to make 15 degrees?
Two of them. How about 45 minus 30?
45 minus 30. So I can write this as sine of 45 minus 30.
Okay.
Now I have the sine of a difference of two angles.
You ready?
I'm ready. Go
Sine, cosine, cosine, sine.
Sine, cosine, cosine, sine. And it's in the way, but I'll get rid of it. Okay, so we have 45 and 30 for both of them. And what are we doing in the middle?
Sine, sine, same, minus.
Same thing, minus. Okay, now all we have to do is simplify it.
Oh, the sine of 45.
Sine of 45 is
Root 2 over 2.
square root of 2 over 2, right off the chart, or it into your head or out of a triangle. Cosine of 30,
Root 3 over 2.
square root of 3 over 2, minus cosine of 45,
Root 2 over 2.
and sine of 30,
1/2.
1/2. Now we'd like to clean it up. When we multiply fractions, we multiply straight across. We get the square root is 6. We can do that because they're both inside a square root. 2 times 2 is 4. And this becomes the square root of 2 over 4. And now that I have a common denominator, I can write this with one denominator, square root of 6 minus square root of 2. And we cannot add or subtract square roots unless they're the same number inside. So we are done.
Okay.
All right?
So we used our sine, cosine, sine to make it easier to simplify, basically.
Absolutely.
Okay.
Now we can know the sine of 15 degrees, and we can all sleep better at night because of it. All right. How about the cosine of 165?
How about it?
How about it? We're going to go back here to our 30, 45, and 60 thing just for fun. 1/2 square root of 2 over 2, square root of 3 over 2. I should really copy this down.
I thought you were going to.
Paste. I kind of forgot to do that. But there we go.
Okay.
Proving it doesn't take that long to make it. Okay. I got to make 165 though. Those numbers don't really add up to 165 because they're kind of small.
Not really.
This
Well,
is-
if it's 165, I want to put 45 in there because it ends in 5.
Okay.
How's that for rationale?
All right. So what else makes 45 plus what?
120.
120. So will that work for us? Do we know anything about 120 degrees?
Oh, it has a 60-degree reference angle.
So
that's
we,
okay.
We can still use our table?
Okay?
So keep in mind 120 degrees is over here. It had a 60-degree reference angle over right here, which means that we're in the second quadrant when we're using 120 degrees.
Okay.
All right, so now I've written 165 as a sum of two angles.
Okay.
I have the cosine of a sum, and what's the silly thing again? I forgot?
Cosine, sine, sine.
Oh, that's right. Cosine, sine, sine. Cosine of 120, cosine of 45. Sine of 120, sine of 45.
Cosine, sine's opposite, so minus.
Opposite in the middle.
Okie doke?
Now we got to do all the cosines and sines, but basically the new part's done.
Yeah. Now it's just
We've
back
applied
to
our new identity, and we just now need to go back to
4A, chapter
chapters.
4A.
Yeah, a long time ago.
Okay, cosine of 120.
Well, it's a 60-degree reference angle, so the cosine's going to give me a 1/2, except for it's in quadrant 2, so it is negative.
Okay.
Cosine of 45?
Root 2 over 2.
Root 2 over 2. Sine of 120. Well, again, it's a 60-degree reference angle.
So root 3 over 2.
Root 3 over 2, and it's in quadrant 2, so
that's
sine
still
is still
okay.
positive. That minus sign is, this minus sign goes with that one.
Okay, sine of 45 is root 2 over 2.
Root 2 over 2 again, and we end up with negative 1 times the square root of 2, which is negative square root of 2 over 4, minus the square root of 6 over 4, which if we get the urge to put them all over one fraction.
Negative root 2 minus root 6.
Yep.
Okay,
You're going to get a lot of root 2s and root 6s over 4.
Yeah.
It's not a coincidence.
Well, it's because everything's based on a 2 over there.
Yeah, so, all right.
Okay, so how can we possibly make this just a tiny bit more challenging?
We put it in radians.
We put it in radians.
Well, we're going to take care of that challenge.
Okay, so the only difference in letter C is that we're doing radians. The difference in letter D here in just a second is that it's a tangent. Okay, so what if it's in radians? What if I have 5 pi over 2? I'm going to come over here.
Well,
I'm sorry, 5 pi over 12.
we could sit there and try to find two radian measurements that add or subtract to make pi over 12.
We could use pi over 4s and pi over 3s and pi over 6s and ew, or
Could we just change it to degrees?
Oh, please. Aren't there 180 degrees in pi radians?
Yep.
Okay, so we're going to multiply, we're going to cancel. We're going to do a little dividing here. Let's divide by 6, so how about a 2 and a 30? So 150 over 2 is?
75.
Okay, so really this is a 75-degree angle. And Mr. Leckie said it's okay, and he's the calc person, so I say it's okay. All right, so this is really the sine of 75 degrees. Okay, so thinking back to our 30, our 45, and our 60, how on earth are we going to get a 75?
I'm going to go with 30 and 45.
Okay, 30 plus 45, I would agree, makes a 75. Oops.
How about a 45 instead
You
of
know,
a
when you
75?
say the word 75 and try to write, or the number 75 and you try to write 45, it doesn't.
45, 75, 55, hike. All right.
Okay, I'm done. Okay, so we've got a sign of an addition, which is?
Sine, cosine, cosine, sine.
Cosine, sine. Sine, cosine, cosine.
She just likes making me do that.
I don't write as fast as he does, so.
You leave more space, though, it's better.
Because I write bigger. Okay, sine of
30,
30,
cosine
cosine of
45, and 30,
30,
and 45.
45, and what goes in the
And
middle?
the sign stays the same. Sine, sine, same.
Sine, sine, plus. Okay, so back to the chart. If you need it, sine of 30 was?
1/2,
Cosine of 45.
square root of 2 over 2,
That sounds familiar. Plus cosine
square root
of
of
30.
3 over 2,
And
square root of
where
2 over 2,
we at? Square root of 2 over 2. And then just a little combining.
square root of 2 over 4,
Plus square root of 6 over 4. Looking familiar.
We've done this a little bit.
Ta-dam.
Yay.
So if it's in radians,
Change it to degrees.
change it to degrees.
And we're right back to where we started.
Okay, All right, on this one we have,
Tangent of negative 15 degrees. It's not going to go away. I don't know
okay,
why.
so tangent. Tangent, ooh, what do we do with tangent?
Tan plus tan over 1 minus tan.
Okay, but we've got
Oh,
a
wait.
negative 15.
We have to write it as a combination
Yeah,
of two
I
angles
got
first.
excited. He got excited too because he did it. Okay, so
All right.
how on earth are we going to take a 30, a 45, and a 60 and get to negative 15?
Well, there's a couple ways we could do this.
See, and you took my chart away.
I did. You want me to write it up there
Yeah.
again?
Come write it down real fast.
Okay.
We'll show them the easy way.
30, 45, 60. Can I just deal with tangent?
Yep.
That'd be 1 over square root of 3, 1 and square root of 3.
Thank you.
Now, there are two ways to make negative 15 degrees.
There are. We could take 30 minus 45.
We could.
We could. But notice that 30 has
That
your
nasty
favorite
fraction.
fraction.
And we're going to have fractions already because we have a tangent thing.
Or we could take
How about 45 minus 60?
45 minus 60 and no fractions. So we're going to be smart here. We're going to use 45 minus 60.
Much
So
better.
The tangent of 15 is the tangent of 45
Minus
60. Be careful, watch the order here because you need a negative 15 degrees. Okay, which we decided a minute ago was tan plus tan over 1 minus tan.
Tan plus, but if it's tan plus tan means the same sign on the top and the
Yep.
different sign on the bottom.
So it's really tan minus tan.
Over 1 plus tan.
Yes. He's doing a great job. If Rex was here, he would be clapping right now.
Rex is here. He's just
Oh.
been ignored for a while.
Okay. All right. So now we just need to figure out what it. Hi, Rex.
Hi, Rex.
What's the tangent of 45?
1
That was 1. The tangent of 60 was
square root of 3.
square root of 3 over
1 plus 1 times the square root of 3,
1 times the square root of 3,
which is just the square root of 3.
which is just, that'll take a whole bunch away.
Okay.
Now, when we went back to Fundamental Identities Day 2, we were showing you some additional strategies. And one of them was something dealing with if you only have one fraction. And if we only have one fraction, we don't really like the bottom of that fraction to be, if you will, messy. So what could we multiply, the top and bottom? We're going to use the special case of multiplying by 1. What can we multiply on the top and bottom to make this 1 plus the square root of 3 go away?
Well,
If you
almost the
will.
same way we got rid of imaginary numbers and their conjugates,
The
if you will.
conjugates. So if this was 1 plus the square root of 3, I'm going to use
1 minus the square root of 3. And minus signs go horizontal. I'm sorry.
Is it Friday yet?
Well, it should be.
It should be. Okay, so we're going to use multiply by a special case of 1 over here, okay? Now, when I do that, I'm going to have to FOIL. So let's get some foliage going here.
Foliage.
Foliage. So very quickly FOIL that out. We're going to have 1 minus 2 root 3s plus a root 9, which is really just a 3. And in the denominator, our conjugates are going to help us with
It's
some
just going to
stuff
be an a
with
squared
canceling.
minus b squared kind of a setup.
Yep, it sure is. And
So
the square
just
root of 3 squared is just
3.
3. Okay, so this is going to make 4
Over.
minus 2 root 3 over a negative 2. Okay? Now, again, still have a fraction, but do we have to have a fraction? Can we just cancel here, Mr. Lucky?
We can, but let's do it the safe way.
We
I
can't
mean,
really cancel when there's a plus and a minus,
no.
right? So we should really
If we do it right, but we'll do it the safe way, the right way.
we'll do it the
How's
right
that?
way.
We
Which
should
means we
factor
have
out
to
a common
factor.
factor of the numerator.
Okay, so again, since I know I'm trying to cancel with a negative 2, let's factor a negative 2 out. So this is going to be negative 2 times what makes 4?
Negative 2
A negative 2 times what makes negative 2 root 3?
plus root 3.
Plus a root 3. All divided by
Negative 2.
negative 2, and that's going to cancel with that. And you can't see it, but it went away.
The board is not cooperating again.
Negative 2 plus root 3.
It looks like a third grader's writing on the board. I'm just here for heck.
He called me weird and third grade. I don't know how to deal with that. But you get to remember sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Tan plus tan over 1 minus tan, tan.
That is all the singing, or as close to singing as
That's
I'm
as-
ever going to do.
That's as good as it gets. Sum and difference. There you go. Lesson 5-3. Say goodbye, Mr. Lucky.
Goodbye, Mr. Lucky. Oh, goodbye.